Welcome and thank you for joining us for today's webinar, 5 AI-powered ITSM myths debunked. My name is Raleigh Gould and I'll be your moderator for today's event. Our featured speakers are Valerie O'Connell, Research Director at Enterprise Management Associates, and Varun Singh, Founder and VP of Product at Moveworks. Valerie came to EMA with decades of senior-level experience in the effective marketing of technology. From strategic positioning with practical go-to-market planning and compelling messaging, Valerie works with her clients to drive business. Varun leads the Moveworks product team. Before Moveworks, he was a lead product manager at Facebook, where he designed an AI solution and chatbot to better recruit engineering talent. And before I hand things over to today's featured speakers, I wanted the audience to know that we will be concluding today's presentation by taking your questions. Feel free to log them anytime. If we do not have time to answer your question, I will send them on to Moveworks so they can respond to them. Also, today's event is being recorded, and you will receive a follow-up email from EMA later today that will include the on-demand playback, a PDF of the slides, and a new EMA impact brief on this topic. So I hope you'll check that email out. And now I'd like to go ahead and turn things over to our first featured speaker, Valerie O'Connell. Valerie?
Thank you, Raleigh, and thank you everyone for joining us today. I'm going to be giving a brief presentation to set the stage for Moveworks presentation, which is really informative and on the topic of AI and machine learning in IT automation. EMA has done an awful lot of research on this as well as field experience. And let's just start off with some high-level findings that across the board, regardless of industry, company size, automation correlates highly with improved business outcomes and perceived competitive advantage. And as I said, that's regardless of industry or what metrics are being used. Automation initiatives have a very high success rate, although they can be complex and confusing to start with for companies that are not used to it. Ultimately, automation correlates with success. So common sense says that if you can do more with less and you can do it better, that's good business. And the gap between enterprises that have high levels of automation and low levels of automation forms something of a de facto competitive gap. If you look at automation gap as a competitive gap, we ask to what degree have you implemented automation in your organization? We asked this of 400 IT executives earlier this year. And we cleverly grouped the answers into 3 categories, high, medium, and low. What's interesting is that while only 26% have complex processes and high levels of automation active throughout the enterprise, 41% have some automation, medium, simple tasks, some multi-step processes, and low is 34% of the respondents. And this was a curated, highly curated list of respondents. They had to have some sophistication in automation and AI. The fact that 34% still rated as low, nothing is automated or in the planning stage, is pretty interesting. That automation gap is one that gets bigger with time because we've found that success breeds success. Automation breeds automation. And that when companies start to experience the benefits of automation, it develops a culture that can consume and capitalize on automation. And that competitive gap widens with time and does so at an accelerated pace. We asked, what is the primary use case for automation and AI? And most companies, not surprisingly, have many automation and AI initiatives. The first one is integrated operations, availability, performance, change management. That's not surprising because operations has had runbooks since the first computer ever was birthed. But what is interesting here is that the next 2 categories are really kind of flip sides of the same coin, having to do with end user experience in the ITSM realm. Self-service capabilities for routine requests and services, and routine service desk capabilities. those combine to kind of ITSM-like capabilities as being the primary use case overall. And on average, those use cases are relatively new. We asked, what were the two most valuable benefits that you achieved from your automation investments? And the first one is the perennial favorite, cost savings across IT, coming in at 28%. Right behind it, improved IT operational efficiencies, which feeds back into cost savings. But here again, we have a combination of focus on the end user experience and satisfaction and the quality of delivered services, which are two different ways of looking at the same thing. In that case, the end user viewpoint leads as the most valuable benefit. Just as an aside, and I'm not going to drill down to it, we found that overall that the benefits that were achieved through automation and AI were usually a very close map to the initial drivers. In other words, benefits sought and benefits achieved were a good map, and if anything, expectations were exceeded. But there were no shortage of obstacles, and we grouped those obstacles into three larger categories, which arguably could be said of any major IT initiative. In this case, it's cost and resources, implementation and experience, and change. First of all, in terms of cost and resources, has there ever been a major IT initiative that didn't find some constraints there? In terms of implementation and experience, these really did bear down on AI, machine learning, and automation, that combination. The lack of skill sets in this relatively new and fast-growing portion of the world, lack of skill sets is a drag. Data management issues, training the machine learning and AI capability is a huge drawback for in terms of an obstacles. Understanding at the use cases and their priorities, finding that the products promised more than they could deliver, and too much customization needed. I think you'll find Moveworks has a lot to say in addressing those obstacles, getting rid of many, if not all of them. Now, change, nobody likes change in general. And here, when it comes to AI and ML, the resistance to change is just stated outright in a lot of cases, but that resistance can take other forms: lack of trust in the technology, job loss concerns, and the organizational conflicts and changes. But summing it all up, the IT automation and AI and machine learning arena is one that is absolutely an executive play. It consistently is moving up in our findings that the budgetary controls, the decision-making, the organizational controls move up in the organization for a number of reasons. One, these initiatives have high visibility within the enterprise. The benefits and advantages that are potentially there are absolutely C-level. Digital transformation itself is making this kind of automation really eventually table stakes. It just needs to be done. And as you automate across processes and across the organization, the control needs to move higher up within the organization in order to make sure everybody plays nice and shares their toys, and so that these processes can seamlessly cross what is otherwise natural boundaries. EMA concludes that automation is an acquired taste, but once it's acquired, it becomes almost an addiction. Success breeds success. As I said, automation breeds automation. So what begins as fear and resistance to change quickly morphs into acceptance and extended use cases, and does this, as I mentioned earlier, at an accelerated pace of adoption. As this happens, it introduces a cycle of continual improvement, which also tends to breed an organizational culture of innovation, and one that can consume automation and is open to it. In turn, these factors translate into competitive advantage, which is where I entered my presentation, and is a good time for me to hand it over to Varun Singh, Moveworks founder and VP of Product. Varun, it's up to you now.
Thank you, Valerie. That was a great introduction. Super excited to be here. And what we'll cover over the next 40 minutes or so is 5 beliefs, myths that we run into about using artificial intelligence to power IT service and employee service overall. But before we go into those beliefs, let me just tell you a little bit more about Moveworks. The company is about 120 employees, a little over 3 years old, headquartered here in Mountain View, California, right by LinkedIn, Google, and some of the iconic companies in the Valley. The leadership experience, a lot of our engineers here, a lot of our team members here have built some of the foundational systems at companies like Google Search, at Facebook, at LinkedIn, as well as ServiceNow. And I'm sure you've used their work. Recently, we announced another round of funding, funded by some of the most eminent investors. It's not very often that you see chatbot companies raise a lot of money, but we've raised over $100 million for solving one problem that's been dogging the industry for about 30 years. And the problem is one of slow IT support. Everyone who works in IT, who's experienced this as an employee or served employees, knows this is a real problem. Employees in general file about 1 to 2 tickets per month. In general, across the industry, we've now seen this at 65 million IT tickets in our data set, and we've corroborated this with industry reports. It takes about 5 hours before someone looks at that ticket. And in general, it takes about 3 days before those tickets get resolved. Now, you would think with the prevalence of simple automation, issues like this, IT requests should not take 3 days. In fact, when we look at the data, it turns out the average handling time for tickets is only about 25 minutes or 30 minutes. So it begs the question of why it takes 72 hours. Well, that's because you need people on service desk to interpret what employees are asking for. When we first started looking at tickets, we were like, well, how hard could it be to interpret IT tickets? Because if we can just solve that interpretation problem and connect it to the right automation, then we can massively speed up resolution of IT issues. And when we first looked at this is what we ran into. Let's think of a simple request, like I need a new laptop. Anyone who works in IT would expect that, well, that's how most employees should ask for a new laptop. The reality is very different. If it's a simple phrase like I need a new laptop, you can use any simple off-the-shelf AI system to interpret what the employee needs. The reality is they express these issues in a wide variety of ways. They use symptomatic language. They'll say things like, I've been working here at Moveworks for 3 years, and my machine keeps slowing down. Is there a policy which allows me to get a new laptop? What they really want is a new laptop. In order to interpret these issues, you need very sophisticated machine learning and natural language understanding techniques, and then connect it to the right level of automation on the back end or right knowledge article on the back end to return an answer for an employee. We know a little bit about this at Moveworks. We've been doing this. We're live at over 40 customers now. We're resolving 35% of all employee-submitted IT issues autonomously. These issues get resolved in an average time of 60 seconds. This includes approvals that need to be processed in order to provision these requests or fulfill these requests or fix those incidents. We have now processed over 65 million IT tickets, which includes about 2 billion IT-specific tokens. And we're serving companies all over this country now, but predominantly on the West Coast. We have tech companies like Autodesk, Medallia, Symantec, and Broadcom. We're serving media companies like Verizon Media, Hearst. We are serving e-commerce companies like Wayfair, Rooms to Go, and financial institutions and investment firms like General Atlantic and Freedom Financial. Now, given all of this background, we understand a little bit about machine learning and AI. And over the course of building this company and talking to hundreds of IT leaders, we've run into a few misconceptions that we thought would be good to go over and provide some insight on. These misunderstandings range from data, cleanliness of data, volume of data that's required to build machine learning systems, chatbots, programming chatbots, effectiveness of chatbots, and finally, operating AI. What does it take to actually operate a machine learning platform live that's performing in real time. So let's start with the first belief. We run into this often. IT leaders tell us, I don't have enough data for machine learning. Going back to the history of machine learning applications, successful machine learning generally relies on a significant amount of data. In the 1990s, text recognition applications were built using 5 million handwritten characters with the training set. Fast forward to 2007, for facial recognition systems, 14 million images were hand annotated, and that's what trained the ImageNet. Fast forward to today, 2019, Tesla Autopilot is trained on 10 billion miles of driving sensor data. If you look at natural language understanding, successful natural language processing initiatives also require a huge amount of data. Google Smart Reply, which I'm sure many of us have used, was trained on 1 billion messages. And all it does is when someone tells you that something good happened, you can say that's great news. Let's move that over to your enterprise. How big is your enterprise data? So let's go through a sample of this. Let's say you're a company of 2,000 employees. If you go by a trend, you probably get about 24,000 IT support tickets a year. If you split that up, 30% of those might be alerts that are logged into the system, so those are not employee-submitted issues, about 16,000 or so employee-submitted IT issues. Out of that, if you want to build a machine learning system, you would carve out some portion of your data for the test set and some portion for the eval set, so you're left with about 12,000 examples for training data. Now let's say you want to build a machine learning system to identify, well, take an example, VPN setup issues. Those would fall under networking issues. You might have 1,000 networking issues in a year reported. If you go further down, maybe 100 of them are VPN related. If you go further down, you may be left with only 10 setup related issues. That is the volume of your training data set. It's not very large. Now, why is training data set important? Let's snap over to how machine learning conceptually works and how models get built. You start with data. You select features in the data you have. From those features, you train models. And then models are used to discover decision boundaries, to classify one example, and draw a difference between two different types of requests, for example. The challenge with small data is, let's say you have a small data space, and you have two different kinds of requests. One is provisional requests for Zoom, which is a video conferencing application. The second one is troubleshooting for VPN. In this case, if you're trying to identify, using machine learning models, what falls above the line and what falls below the line, essentially what is a provisional request for Zoom versus what is troubleshooting for VPN, you can draw a decision boundary anywhere, okay? But once you start, and that's why, if you try to do this on POCs, you try to build pilots, and you do it with small data set, basically any machine learning model will be able to separate some simple utterances. The reality is, once you see live data, once you see the actual representation of how employees ask for things, how employees file tickets, you get the true data distribution, and suddenly your decision boundary is wrong. The true decision boundary looks something like this. And when you get the decision boundary right, you can disambiguate very, very fine utterances like, I managed to get on VPN, how do I connect to a Zoom meeting? Versus, I need to get on a Zoom meeting, how do I connect to VPN? So the challenge with small data is because you don't have true distribution, it's impossible to come up with the right decision boundary. And you need a big amount of data to come up with a true decision boundary. So how do you get big data from small data? That's the essence of the question. Well, at Moveworks, we've pioneered 3 different techniques and applied them specifically for understanding employee-submitted IT issues. One is transfer learning, second one is meta learning, and the third one is selective learning. I'll go in depth with transfer learning in this particular section. With transfer learning, what you're doing is, let's say in this case, we have a specific domain of IT where our training data isn't very large, shown in red on the left. Purple on the right, you might have a tangential domain which has a very large data set. But it's not domain specific because it's not IT aware, it's a related domain. What you can do is you can build models on that larger domain that develops generic knowledge and then apply that model and enrich it with IT-specific data to make predictions in IT. What does that mean specifically for IT service issues and what we do at Moveworks? I'm sure all of you have used Stack Overflow. Stack Overflow is where engineers go often to ask questions, report their issues, and essentially it's a very large repository of troubleshooting type questions or request type questions. And there, if you pay attention to what's highlighted, the language patterns, how can I disable the cache temporarily and refresh the page in some way that I could see the changes? Right-click and choose to open the dev tools. Click network and the toolbar to open. These are generalized language patterns that would be seen in IT tickets themselves. And you can learn these generalized language patterns and bootstrap your machine learning models using tangential data, and then transfer that model over to IT-specific domain, which massively improves the ability of these models to disambiguate different kinds of language that employees use in IT service issues. And if you actually see that in action, on the left is unsupervised clustering of IT tickets without transfer learning. And what you're seeing there is essentially an unsupervised clustering model trying to identify different language patterns. And if you look at the structure of the patterns that are being detected, it's seeing a lot of different overlap, and it's not able to identify structure very clearly. But on the right, when you apply transfer learning from a different domain, which has generalized learnings built into the model, and then apply it to IT, you see that the structures come off extremely clearly, and the system is able to pick out patterns without a large amount of data coming directly from IT because it's trained on a tangential domain. So the belief that you don't have enough data for machine learning might as well be true, but that doesn't stop you from building, or companies like ours from building really high-quality machine learning models and serving smaller enterprises or enterprises that themselves, even large enterprises, don't have a ton of data to train machine learning models. And the reality is, if you find the right tangential domain, you can transfer learn from that domain and apply it to IT data, which eliminates the need for big data. Let's go to the second belief. Machine learning requires lots of clean data. We've run into many of our customers, prospects, who talk about how their IT ticket data is not very clean. It's not labeled very clearly. They don't have CI and CNDB established very well. They don't have categorization done really well. They don't have assignment groups done really well. But before we go into the genesis of that belief and how that impacts machine learning, let's go back to machine learning quickly. What does label data even mean? We went over this whole cycle previously of data, selecting features from that data, building models, and establishing decision boundaries. Label data essentially is when you're selecting features from a certain data set, the original data has to have some labels because the model will essentially try to predict those labels when it sees a new utterance come in or a new phrase come in. And clean data essentially means that your label data is correctly labeled, often called the golden set or the true set. What does that mean? Let's go through a labeling exercise together. On the left, Matt saying, how often does my password expire? On the right, David is saying, can you get me access to Zoom, please? Now, if you were to put a label on what's on the left, is it an information or is it an action that Matt wants? Well, the right label is that that's an information. On the one on the right, where David wants access to Zoom, he's looking for action. He's looking for someone to provision Zoom to him. That essentially is a labeling exercise, and your data needs, admit this, your data needs to be well labeled for machine learning models to learn from. And what supervised learning models are doing is, given an input data set, they're predicting what the label should be, and for training, they need labeled data sets. So how does my password expire? The prediction that the system will try to make, if that's an information question. Now, yes, there is a ton of labeled data set required, but what if your use case is common across the industry? What if what you're doing is not unique? And this is what we've seen with IT ticket data. We've now seen, like I mentioned, 65 million IT tickets. We're adding about 500,000 to that corpus on a weekly, monthly basis. And what we notice is IT ticket data is homogenizing. There's a significant overlap in terms of the IT issues that employees are filing, not just in the language patterns, but also specific things that they're complaining about. If you think about web conferencing, every organization either has Zoom, WebEx, GoToMeeting, or Skype. If you think about hardware, laptops, MacBooks, Lenovo's, iPads, etc. These are all fairly homogeneous in nature, and therefore the issues surrounding them are also homogeneous. Which brings me to the technique that we've pioneered here at Moveworks in order to provide high coverage, high precision models for understanding IT issues and resolving them. And the technique is called collective learning. What collective learning does is that it learns across similar problems across many different organizations. These are three different organizations, A, B, and C. On the left, the organization's using Zoom. So you see issues like I need Zoom for meeting access. When I connect to Zoom, there's no video. How do I enable Zoom? In the middle, organization B is using WebEx, and you have a bunch of WebEx-related issues. Organization C is using Google Hangouts. They're talking about TV and Google Hangouts are not working in the room. My mic in Google Hangouts doesn't work. Very disparate issues, but you're beginning to sense that these are all related to video conferencing, and it's employees either asking for access or troubleshooting about video conferencing. What collective learning does is the first step is it tokenizes all of these utterances and abstracts away organization-specific entities. So here, $VCA stands for video conferencing application. And once you encode all named entities with video conferencing application, suddenly all of these utterances look exactly the same. The language begins to get generalized. And if you blend all of this data together for building machine learning models, there is no sense of one organization being different. The data has now been enriched through collective learning across all of this data set. The second thing on top of this that can be applied to this is a technique called language generalization, which we use to create our own synthetic data. So let's look at these three examples. Varun saying, I need a license for Zoom. Jose says he needs, can I get Confluence access? Sarah saying, please give John a Trello account. If you look at the language pattern that sits underneath, it's a person who needs a license for a software. The second one is person gets access to a software. The third one says give person software account. That is the generalized language pattern. If you combine this combinatorially, suddenly you go from three utterances to dozens of ways in which someone could say the same thing. And this language generalization suddenly, beyond just collectively learning across organization, further multiplies the amount of data an organization can have or to build a machine learning model. That's essentially what we do at Moveworks. We take in data from across all of our customers, tokenize them, do generalized learning across this data set, and then apply those models to each specific customer. Of course, those models, there's a private component to those models in which we learn enterprise-specific entities. But just out of the box itself, let me tell you the quality of predictions that we've seen in the real world. We just train on your data exclusively. That means we don't train across the organization. It will take a certain amount of labeled data, labeled tickets to get to a certain level of quality. With Moveworks, on day one itself, without pre-training or enriching our data set with your data, collectively learning across 10 orgs of data, we already start at a high level of prediction accuracy than you would ever attain if you were to build a model with your data set. And as the data keeps getting enriched and we combine your data, the quality of our prediction keeps getting better. And you'll notice that we asymptote at a value that's significantly higher precision. In fact, what we notice is if you train on the best organization's data, you might get to 70% precision. With Moveworks, out of the box, we're at 85-90% precision. And when we enrich with your data, which happens within an order of days, pre-training, we can easily go up to 95-98% precision with 95% coverage. So the belief is machine learning requires a lot of cleaning data, but advanced machine learning models, in fact, no one has clean data because no one was ready for machine learning to come and start adding a ton of value from day one. Advanced machine learning model works even with dirty data because of the way the product or the technology gets architected and the nature of the domain itself and starts delivering value on day one. Let's go over the third belief, enterprise search. Something that's very common for all of us. The belief is that keyword tagging is the only option for building enterprise search. Let's look at Google search today. I'm sure this is an experience that many of you have. Not exactly the question I would ask, but if you ask Google how much muscle can you gain in a week, it returns the exact paragraph that answers that question. Today, this technique answers about 10 to 12% of all Google queries. That's about 200 million queries a day. Two of the people who founded this team within Google are now leading our search initiatives and leading all of our machine learning. One of my co-founders founded this team. And it's you'll realize how important search is to enterprise, because this is the experience that employees, that people, consumers world over look for. But if you look at enterprise search, it's still far from ideal. Here, you're seeing some representative results. How do I set up my Java environment was my question. The result you see, the first one speaks for itself. Email interruption tonight at 11 p.m. Eastern. You'd hope the second one gets better, but it only gets worse. It says, how can I find MAC address of my Ethernet wireless interface? Not very useful. Why is enterprise search still broken? Let's go over that. First is the data advantage that consumer search companies like Google have. Google has about 12 billion internet pages that it scours, versus an enterprise might have anywhere from 50 to 5,000 pages. It's not a ton of data from a supply perspective. Secondly, Google sees hundreds of millions of queries every day, which allows Google to constantly understand and evaluate how people rephrase queries, what people are looking for, etc., and that bootstraps and powers their search system. Whereas enterprise, you don't see that level of query volume. Second thing, keyword tagging is extremely brittle. Let's look at a query. Can someone help issue me a new laptop? The keywords there are help, issue, and laptop. The document that gets returned is help with common laptop issues. That's not what the user is looking for. Keyword tagging also ignores syntax. So let's think about three keywords: process, order, and monitor. The first question is, what is the process to order or monitor? The second question is the user saying, I need to monitor the order process. And the third one is, I can't process a monitor order. These are three different questions which use essentially the same keywords. If a search system is powered by keywords, it has no way to disambiguate these three questions from each other. Keyword systems also don't have an understanding of named entities, and they can't disambiguate things. So if a query like what is box comes in, what is, and the question mark gets wiped out, box is the keyword, and the system returns a document saying how to order a cardboard box. That's completely devoid, it is devoid of understanding of what the question was itself. Lastly, enterprise search tends to be very symptomatic. What we've noticed after reviewing about 65 million IT tickets is employees generally don't know what they're looking for, but they use words and language to describe what they're experiencing. So Natalia would say, my laptop monitor turned blue, but she won't say, can you please show me the Windows blue screen of death error troubleshooting guide? Similarly, Mark would say, I need to request paternity leave, but he won't say, can someone tell me the process for California paid family leave claims? And therefore, even if keyword systems work, keywords that appear in employee questions often do not appear in answers that employees are looking for. So given all of these confounding factors, how do you deliver modern enterprise search? Well, the answer is actually pretty simple. You have to understand the question really well. You have to understand the nature of answers, and then use great machine learning techniques to match the question to the answer. Let's start with the first step, understanding the question. Machine learning helps understand the sentence context. So let's look at sentence here. How many attendees can Zoom meeting support with two-way audio? Here, the focus word is how many, which predicts that it is likely that the answer will contain numbers. The core topic entity is Zoom meeting, which could likely be the topic of the answer. The context is two-way audio. It is likely that that will be mentioned in the answer. So when a machine learning system interprets a question, it's trying to unpack the way a question is structured and trying to predict what it should go look for in an answer in order to successfully answer that question. Another technique that gets used is word embeddings. It's a technique to find relationships between words. If you take all words that appear in the English language and you put them based on where they appear in a sentence in a vector space, you'll find that words that have the same meaning end up very close to each other in proximity in this vector space. So when someone asks a question like how many attendees can Zoom meeting support with two-way audio, the answer might not say attendees, it will say participants. And natural language understanding techniques know that attendees and participants essentially mean the same thing, because in the vector space or the word embedding space, they appear close to each other. Another important aspect of applying machine learning to understanding queries is identifying synonymous words and phrases. Identifying synonymous words and phrases allows a machine learning system to retrieve all relevant answers for a given question. So when someone asks, my laptop won't power up, using machine learning techniques, some of the ones that I just described, you can create other equivalent queries and then go use those queries to retrieve answers. So the alternative queries for my laptop won't power up could be things like my computer won't start, computer not starting, MacBook won't boot, has black screen, etc. Now, once you've understood questions really well, the next step is to understand the answer. Now, when I talk about an answer, I'm literally talking about an answer, which is an exact paragraph or set of paragraphs that answers an employee question. It's not a set of blue links. That's not what employees are looking for. That's not what consumers are looking for. Everyone's looking for answers. What Moveworks does is no matter what nature or shape your answers are in, we have techniques that automatically snippetize your document. And then within each snippet, we characterize the type of answer that snippet contains. So the first snippet, you see highlighted, it says Slack uses standard emoji codes. That's a factoid. Given an answer, we'll predict what kind of question that snippet could answer. The second one is a series of steps. It says 1, click the smiley face, 2, use the icon. That snippet could likely answer questions like, how do I use emojis in Slack? Could be an answer to an how-to question. After you've characterized answers and understood questions, what remains is matching the answer to a question. Here's where we've really pioneered application of something called sequence-to-sequence. When you go to Google Translate and you type in a phrase in Chinese, a sequence-to-sequence model translates it to any given language. You end up with Bush held a talk with Sheriff. That's what the Chinese have taught me. The sequence-to-sequence can also be used to translate questions to answers. So if someone says, can someone help issue me a laptop replacement, after it runs through our sequence-to-sequence model, which is, by the way, just one of the techniques we use for ranking answers, it spits out an answer that says, request a new laptop using this form in ServiceNow. Now, that particular answer can be found in a snippet and will allow for great retrieval and relevance for the answer. So the belief that keyword tagging is the only option for enterprise search actually is not right. High-quality enterprise search requires natural language understanding and machine learning. And finally, we're seeing companies like ours who are pioneering these techniques and delivering great results for our customers. This brings me to the fourth belief. Everyone's used a chatbot of some sort, and there's a belief that you can use a bot toolkit to create a conversational AI system. Many vendors provide them. I'm sure you yourselves use some. Let's go through an example of some of these interactions. This is on a rather large messaging platform. I am chatting with an e-commerce bot. I say sandals. The bot comes back and says, I found these sandals for you. The first one is a black leather sandal. The option that I have is see all colors. Now, given that it's a natural language interface, most of our users don't actually pay attention. Most consumers don't pay attention to what the bot wants them to do. They just go ahead and ask. I went ahead and asked, what sizes do these shoes come in? An absolutely relevant question, given that I was just shown shoes. The bot doesn't understand that at all and says, we're sorry to hear about your problem with your shoes. To best assist, please email. Not an ideal experience, not even close to it. In this case, the system was looking for a rules-based match. The conversational designer had specified that the user is only allowed to talk about colors, and the system was looking for that. There was no concept of various slots that are required for a sandal, which could be color, size, heel size, etc. Let's look at another example. This is a famous travel booking bot. I go ahead and say, I need to fly to Boston. The system understands that and says, great, where do you need to fly from? Now, it's pretty obvious that it is looking for a location, but I just go ahead and say, hey, what's the best price? I assume that given who I am, the system knows my identity and where I would fly from. Instead, the system does a greedy match. It comes back and says, looking for flights from Price, Utah to Boston, Massachusetts. In this case, not only did the system not understand what I was looking for, it went ahead and picked out one word that it matched against a dictionary of cities and assumed I was looking for flights from Price, Utah to Boston, Massachusetts, which is considered a greedy match, not exactly what I'm looking for. I didn't even have the heart to show you what the rest of the conversation looked like. It was painful. Why do these systems fail? Now, the reason they're failing is that essentially these are hard-coded rules-based approach. Some conversational designer has prescribed exactly what the user is allowed to say and exactly what the machine will look for in terms of populating a response to a user. So there's failing in two different ways. One, the user has to try to guess what is it that the designer wanted. And even if they say something else, the designer has trained the machine to only look for what they wanted the machine to look for and not what the user is asking for. These types of techniques don't work, clearly fail, as shown by these examples. Now let's go through what an experience with Moveworks looks like. This is Slack. Moveworks works with Microsoft Teams, Google Chat, any of the other enterprise collaboration platforms. Alex comes in and says, can you add me to the sales DL? Moveworks runs through a ton of machine learning models and comes back in real time and says, hey, Alex, looks like you're trying to add yourself to a group, and links to my records and is able to find 4 distribution lists that are a relatively close match. I will unpack the extent of machine learning model that goes into interpreting that sentence in the next belief, so hold on for that. Now, what would you expect Alex to say? As a designer, you would say, hey, Alex, make a choice, say 3, or say inside sales at Moveworks.us. What does Alex say? He changes his mind. He says, actually, I'd like access to Trello first. This is a nightmare for bot designers. And this was a nightmare for us 3 years ago when we started the company. But what Moveworks does is it anticipates what Alex is looking for. And the way a conversational AI system is designed with the machine learning system at its heart, it's trying to have the conversation that Alex is trying to have and not trying to force Alex into a conversation that it is trying to have. Now, system understands what Alex wants. Alex goes ahead and says, yep. The system goes ahead, integrating with systems like Active Directory, Okta, or SailPoint on the back end, provisions this application, and creates a ticket in the ticketing system. That ticket is essentially a receipt. No one has to work on it. It's only there for compliance and governance purposes. Now Alex comes back and says, can you add me to that inside sales? Damn you, Alex, is not making it easy for our bot designer to keep up with the conversation. But guess what? There is no bot designer here. It's a machine learning system that's trying to interpret what Alex is trying to do. It has complete context of everything that Alex has said to a system, much like when you open your messaging system or your chat system and you see talking to friends, your partners, your family, things are always out of context. And you use your ability to understand everything that was happening in the chat to predict what is it that the person you're talking to wants. So in this case, no problem. Moveworks understands that it had an open context, understands that Alex wants inside sales. By the way, he didn't say free. He didn't say inside sales at Moveworks.us. He literally said, can you add me to that inside sales? System understands that request. Alex goes ahead and says, please. He doesn't even say yes. System understands that. Goes ahead and adds Alex to a distribution list, and job done. That was an absolutely magical experience. And the reason for that magical experience is that our system is driven essentially by machine learning that understands who the user is, that understands what the user is saying, that understands the context of the conversation, and uses that to piece together what is it that it should do next. And that's why we have several customers now, over 3 dozen, that are using the system to resolve IT issues, several employees getting value from this every day. And the reason this works, like I just mentioned, is because we're using a machine learning system that combines data from multiple backend systems and what the user said to interpret and on the fly determine what should be said next as a response to the user in order to carry on the conversation and take it to a logical place where the user gets value or accomplishes something. There's real utility in our system. It's not a generated system that's just trying to carry on the conversation and waste an employee's time. So the belief that you can use a bot toolkit to create a conversational AI system, you can use a bot toolkit to create a system, I don't think it'll be conversational or AI. You'll end up with a lot of jokes and a lot of ways in which it breaks. But for a focused domain like IT, a conversational AI system must be driven by machine learning models for it to scale and delight employees on a daily basis and fulfill their issues and requests. Brings me to a fifth belief. Often, you'll believe that all I need to do is build one machine learning model, and that's sufficient for making predictions in natural language understanding. There's many providers, ranging from very large internet companies here in the Valley to many enterprise software companies. They'll give you a tool set and say, hey, use our tool set, and it's very easy. You just build a machine learning model, and you'll make great predictions from it. I showed you this example, or a similar example. Let's see what it takes to go from natural language to action. Alex saying, how do I add Bhavin to the marketing group? And the desired result is Bhavin gets added to the marketing North America email group, and a receipt gets created in the ticketing system, and Bhavin gets notified. And let's unpack this. Starting at the top, the first thing Moveworks does is it runs through spell correction models. You might not have even noticed it, but Alex said, how do as a single word. Well, that has no meaning. So a spell correction model automatically spell corrects that to how space do. In fact, we understand enterprise-specific entities and org-specific entities, which means something like Okta will not get spell corrected to Okra, a loaner will not get spell corrected to a loan, because these are legitimate enterprise entities. Out of the box, Moveworks understand. Following that, it does named entity recognition. Here, it is tokenizing the specific named entities in order to establish just a generalized language pattern on which the model will get trained. Following that, there are statistical grammar models that the system runs them through, which looks at phrases and what words are occurring together in order to determine what is it that Alex said. So in this case, Alex talked about email distribution list. He was trying to add someone. The token he was trying to add was Bhavin. The group he was trying to add Bhavin to was marketing. Following this, all of this information. Now, not only did we run several machine learning models in sequence extremely fast, they are passing information to each other. And finally, it goes to the intent model, which determines that given everything, it looks like the user wants to manipulate a distribution list. And the second best intent is users looking for instructions on how to manipulate a distribution list. Following this, it goes to record linkage models. Because remember, at this point, the system actually doesn't know if Bhavin exists in our data set or marketing exists as a distribution list. Our machine learning models that rank entities inside your directory, inside your enterprise, comes back and says, well, I was able to find a unique Bhavin, but for marketing, I was unable to find a unique match. Guess what? Then it passes it to a conversational AI model, where the user then has to make a choice and tell the system what is it specifically that they were looking for. And those are disambiguation models that have to run on the fly on a conversational AI system, which can never be prescribed upfront. Following this, the final request gets created, and then the action takes place. So even for a seemingly simple example, like how to add Bhavin to a marketing group, the system had to run through several machine learning models at a conversation speed. So the belief that you only need one machine learning model is sufficient for making predictions is actually absolutely incorrect. Most people shouldn't believe that. The reality is high-performing machine learning models that have high precision and high coverage and high speed rely on a technique called ensembling of models, several models working together to deliver high-quality results. I also have a bonus belief. I'll cover this fairly quickly. Once you develop a model, the belief is you can use it forever. In fact, you might have done POCs, and during the POC, the model runs fine. You leave it running for 2 months, sometimes 2 weeks, sometimes 2 days, and suddenly the model degrades, and its performance becomes terrible, and it cannot make predictions anymore the way it did at the POC stage. Let's talk through why that's important. Machine learning models need to respond to data drift. Let's look at this example. Everything in red up top is how do I get Lucidchart. All the blue dots are I'm unable to save diagrams in Lucidchart. There's a troubleshooting for Lucidchart below the line. Above the line is how do I get Lucidchart. A machine learning model has established a fairly good decision boundary for this data set. On the top, it will try to provision it. Below, it will say, I'm not going to provision it. Those are troubleshooting requests. That's the prediction it's making. Now, let's see how data evolves over time. Suddenly, the shape of data will change. And based on the new shape of data, your machine learning model will need to evolve. If you had the previous decision boundary, the machine learning model will not be making good predictions anymore. So a machine learning model has to respond to data drift, has to respond to the distribution of data changing. How do you do that? What sits underneath machine learning models is data flow. We know that. A lot of our team comes from companies that built some of the pioneering machine learning systems you use today. In fact, we ourselves have a very sophisticated system that underpins our machine learning platform. What this machine learning data flow consists of is 4 key stages. Monitoring. Monitoring implies the system is we're always evaluating how our system's making predictions. Part of that is predictions get sampled and go over to our human evaluation team. Our human evaluation team is now several dozen people, and these are trained specifically in IT utterances, and they go through a 4-week apprenticeship program. And then they annotate, and essentially what they're doing at that stage is correcting the machine or making predictions of whether the machine was right or wrong. This gives us a labeled data set. This labeled data set that goes into our training cycle where machine learning engineers have the best-in-class enterprise-specific data on which they're training new machine learning models. Then these machine learning models go through an eval cycle where they are evaluated against test data set to see if the predictions are making, the new predictions that they're making are an improvement over the previous prediction that's being made, and after that, they get deployed. This whole cycle happens several times a day, several times a week at Moveworks, depending on the nature of machine learning models, and it's our responsibility to make sure our machine learning models are always performant, always increasing impact in your environment across spell correctors to figuring out intent of what employees want and search, the entire gamut. So a model used once is used forever. That's actually not true. It needs to be rebuilt over and over again, and for that you need an underlying system that's always rebuilding these data models. They're always being retrained because data drift is real, and you always need machine learning models to evaluate that data drift and respond to them meaningfully. So just a recap of common AI beliefs, the belief that I don't have enough data for machine learning. The reality is you can train off of tangential data sets that have a vast amount of data to develop generalized understanding and then apply it to your data set for predictions. Belief is machine learning requires clean data. While that is true for naive machine learning models, advanced machine learning techniques work even with dirty data. The belief that keyword tagging is the only option for enterprise search. Well, high-quality enterprise search requires natural language understanding and machine learning to understand the intent and semantics of what the user is looking for, which keywords are often devoid of. Belief is I can use a bot toolkit to create a conversational AI system. You can certainly use a bot toolkit to create a system. I wouldn't call it conversational or AI. For a focus domain, you need a conversational AI system. It must be driven by machine learning models, and it delivers delightful results for its users. One machine learning model is sufficient for making predictions. That's not true. High-performing machine learning systems rely on an ensemble of techniques that all need to work together to make predictions. Lastly, a model developed once is used forever. We wish that was true. Your data drifts. With AI, you need to constantly train and retrain your model, and the underlying system that's required to retrain models is real because data drift is real, and machine learning models need to keep up with that data drift. Now, here's some more follow-up information. All the techniques that you saw here, we have pioneered them at Moveworks. We're applying them to resolve IT issues for many of our customers. Up to 35%, 40% of all IT issues are being resolved every week for many of these customers. So if you're interested, reach out to us, and we'll show you what the live system looks like in action. Back over to you, Valerie and Raleigh.
Great. Thank you, Varun. I will be sending a PDF of this deck out too, so if you missed anything or want to revisit any of the information, you will be able to do that. And of course, you'll be able to access these valuable resources as well. I'm going to go ahead and jump right into the questions. Varun, the first one I'll address to you. It is, I've built a lot of workflows and automations already. Does adopting an IT bot mean that I have to rebuild all that?
That's a great question. We run into many of our customers who have done a ton of automation already in the enterprise. the short answer is no. You absolutely don't need to rebuild automation for use or consumption by an IT bot. In fact, many of our customers, we'll talk to them and they'll say, well, we've automated 30% of IT issues, and when we actually look at ticket data, only about 5 or 6% of their issues are being resolved by the automation. But there's way more issues that could be resolved through this automation. And the problem that's arising is today, employees have a hard time finding the right catalog item, the right request, the right button to click to get help for their issue. Because employees only run into these issues about once a month. So they don't, and every time it's a different issue. So they don't remember where to go. With a chatbot like Moveworks that lives inside their enterprise collaboration platform, they can ask for that, or they can express their symptom in natural language, and Moveworks will automatically connect it to the right automation, understand exactly what that automation needs, ask the follow-on questions from the user, and then fire off that automation that you've already built inside the enterprise IT organization. So yes, you absolutely don't need it. In fact, anytime a ticket gets created inside a ticketing system, Moveworks reads it within 5 seconds, interprets it, parses it through a machine learning platform. And if there is an existing automation that resolves that issue, we will reach out to the employee saying, hey, we can resolve this for you right now. You don't have to wait for someone on IT to resolve it. The employee doesn't have to remember where to go for any of these issues.
That's great. Thank you. And can you also discuss what's the typical implementation timeline for an ML-powered IT resolution service?
If you're talking about a generic ML-powered IT resolution service, I'm sure you've probably heard it takes several months of training before a system can go live. Someone will say 6 months, someone will say 9 months. The reality with Moveworks is very different. We've had very large customers, 50,000 employees, 80,000 employees, go live within 4 to 8 weeks with our system. And that 4 to 8 weeks actually encompasses several things. None of them are machine learning related. Moveworks, because of our collective learning, because of our ability to understand IT language so well, comes with machine learning pre-trained, as I showed in one of the beliefs. What that process of 4 to 8 weeks is, essentially it's 40 hours of work on our side where you give us access to certain key systems and we configure the Moveworks platform to operate in your environment. We do automated testing internally first to make sure the system's working well. We hand it over to IT, and IT tests it. After a few days or weeks of IT testing, it then gets expanded over to a few hundred users within the enterprise. Once that passes, it gets rolled out to all employees. It takes about 4 to 8 weeks for the system to go live. To give you an example of day 1 impact or week 1 impact, some of our recent customers, one of them was a 12,000 employee company here in the Valley. When they went live, the company's been around for 30 years, so it's by no means a cloud-first company. First week resolution was 47% of their IT issues resolved by Moveworks. So that's the level of impact we're talking about on week 1 itself.
Thanks for that insight, Varun. That does bring us to the top of the hour. If you had a question that we were unable to answer, I will send that on for you. And as I mentioned, I will be sending out a follow-up email with resources from today's webinar, so I hope you will check that out. Thank you for taking time out of your schedule to join us, and I hope we'll see you at a future webinar. Thanks again for joining us, and enjoy the rest of your day.
Thank you. Please stand by.